2 more here, and then we'll go from there. So 81 to the power of 3 over 4. Again, same process. I want you guys to do this one for me. Just have a go. See if you can write it down properly. Even if you can't calculate the roots and do the powers, just see if you can switch it from that fraction to the root. Hopefully, you ended up with something like this. The power here was 3, so I'm going to write it out back. The root was 4, so I'm going to write it in front. And I end up with 81 under the root 4, and then raised to the 3rd power. Number times itself 4 times, which gives me 81. It's going to be 3 cubed, and 3 cubed is 27. Avery's asking a question about the quizzes. On the quizzes, when it says write in simplest form, do we evaluate it or just write the question in simplest form? I guess it kind of depends on the question. If you have numbers with exponents, which are numbers, then you're just going to, calculate it through. Generally speaking, if you have something like that, it'll say evaluate. So you're going to find the solution. If you have a question that just says simplify, you probably have like variables in there like x's and y's. So you want to make sure that you've just simplified the exponents as far as you can go and things like that. So if it says evaluate, generally you have numbers to deal with. If it says simplify, you probably have variables in there. So you won't actually be able to get to a number. Hopefully that kind of makes sense. And you kind of need to judge by the solutions that you see there as well. I don't know if that answers your question, but use your best judgment, I guess, is what my answer is. It's different for each question. Last one, 0.75 to the 1 over 2. Or sorry, 1.2. I'm going to put in a little note here. 0.75, the 1/2, or 1 over, or 1.2. If we don't have any perfect roots, we have to use our calculator. So I don't have a perfect root here. 0.75, it's not a perfect cube, it's not a perfect square, it's not a perfect 4th root. The 1 over 2 I could rewrite as 12 over 10, but that really doesn't get me very far. So what I can do is I can write this as 0.75 to the power of 12 over 10, which is the same thing as 0.75 to the power of, if I simplify that, 6 over 5. It's not going to work out nicely. I could write it like this, the 5th root of 0.75 to the 6th power, but I know that the 5th root of 0.75 isn't going to work out very nicely, and then the 6th power is not going to work out nicely. So I'm just going to end up with a decimal here. So we might as well find what it is just to work on our calculator a little bit. 0.75, I'm going to go x to the y, I'm going to use a bracket, and I said 6 over 5, so 6 divided by 5. I'm going to close my bracket, check that everything looks okay in there, and then I'm just going to go with equals and see what I end up with. So it's just this mess of decimals. So 0.0708, maybe I'll just go with that. 0.708. So that one didn't have any perfect roots. It's not going to work out nicely. just kind of how these things go sometimes. Generally speaking, the majority of questions you'll encounter, they'll work out very nicely for you. But every once in a while, you'll see one of these curveballs, and it's this 0.75 to the power of 1.2, and it's just going to be a decimal, and there's just nothing you can do with that other than just writing it as a decimal. 12 over 10 is this 1.2, so 12 divided by 10 is 1.2, just converting the decimal to a fraction. All right, I'm thinking that's that. And I'm thinking that's some math for today that you guys have seen. So like I said at the beginning of the class, maybe if you signed in late, you didn't catch me, but Mrs. Ward will not be doing English today. So I'm just gonna continue on here. But we're gonna probably take a little break here. So if I just take a quick look at the course back in Moodle, we did this lesson last day, lesson 2. And there is an extra practice sheet that I've included here that I really think it's valuable if you guys go through it. So I'm just going to open that up. This is all of the negative exponent stuff that we did last day. So the learning guide's great. It has some examples in it, but it doesn't have enough. And I know sometimes doing more and more, if you're not getting them, or if you really understand it, isn't going to be a lot of a benefit. But the thing with this sort of section is there's so many different types of questions you're going to encounter. We can put exponents anywhere. You can end up with negatives and positives or fractions. You can have exponents inside the brackets, outside the brackets, and just kind of the next section we do kind of just, it's just everything all on you all at once. So I strongly encourage you guys to try a few of the extra practice ones I've included here, just so you can kind of get a feel for what sort of things you're going to encounter. Let's take a quick look at the learning guide. I asked you guys to do up to 12. You had some negative exponents there, but nothing crazy in terms of fractional exponents or rational exponents. So hopefully you had a chance to do that. I'm going to give you guys 20 minutes here. You can grab a drink and a snack. I know I'm pretty hungry. Taylor has some questions. I'd like you guys to do just a little bit of work and just work through these questions. So I want you to try some of question number 13 on page 7. Those are tricky. Maybe try A and C if you haven't done those yet. I mean, you're going to do all of them, but in the next 20 minutes, I'd like you to just try these. Rational exponents. Maybe try number 4, A and C, 5, A and C. So that's on page 8, 4 and 5, A and C. And then we'll just take a little break to there. So I think that's probably about 10 minutes of work. There's 6 questions there I'd like you to do. Page 7, 13, A and C. Maybe I should write this down. Page 7, number 13, A and C. And page 8, number 4, A and C, and number 5, A and C. So try those 6. I'll go through anything else you have. After the break, I'm going to answer any questions you guys had about this or anything else in the learning guide, and then I'm going to go on to the kind of application stuff. So we're going to look at all the rules all at once. But for now, I just want to get you guys into the fractional radical stuff. So we're going to leave it there, 20 minutes. Have a little go at those. Grab some sugar, something good, fill your belly, glass of juice or something, bring you some brain power back, and we'll see you guys in 20 minutes. All right, guys, welcome back. Hopefully you're there. If you're not there, hopefully you're running towards your computer. If you can give me a green check just so I can make sure things are kind of going okay and you guys are all back with me, and we'll just continue on once we make sure everyone's ready to go. There we go. See some checks coming in, so everything seems to be okay. Apparently people took an extended break, 30 minutes or so. All right, so I left you guys with 6 questions just to look at, see what you can do with them. I'm sure there'll be a few questions about them, and I don't mind going through them. The next, I should probably just look. I think there's 2 more lessons in this unit, and the next one is just kind of everything all put together. So we have lesson 3, which we just did today, lesson 4. So there's only one section left, applications of exponent laws. So I kind of want to spend a little bit more time on this stuff because I understand it's a lot. And I know from teaching this course a few times that of all the sections that kind of get confusing, this is kind of the point. So we've introduced all the individual laws. When we multiply, we add. When we divide, we subtract our exponents. We've looked at negative exponents, you take the reciprocal. And when we do each of the individual things, it seems pretty straightforward. But then when we throw them all together in one big question, it just kind of breaks down. There's just so many steps to these things, and they're so overwhelming to just look at. So the most important thing is you just pick something and you do it. So if you're going to do your division, go for it. If you're going to get rid of your negative exponents, go for it. Don't try to do everything at once. Just take it a step at a time. So they get a bit involved. So I see some questions in chat. Page 7, 13C. 2 people have asked for that, so I'll do that. And then page 5, 2B. I can get to that one as well. Anything else? Maybe just look quickly at the 6 questions here that we assigned. So first one was page 7, 13C. All right. Let's do this one first, and then maybe I'll go over one of the next question as well down below on page 8. So the first thing we want to do is you can start wherever you want. And I think it's important that you guys figure out which way you like the best, and you just stick with that. There are sort of many, many paths to the right answer. It's kind of like if you're driving somewhere. You guys, I guess, aren't driving yet, but I love driving. So if I'm going to, let's say, Vancouver, there's lots of ways to get to Vancouver. You can go to Vancouver going through Merritt and then down the coast, or you can go the whole Princeton. You can go down through Princeton and over, or you can go from Merritt across and then down Highway 1, kind of like through Kamloops there. So there's lots of different ways to get to Vancouver from Kelowna, just like there's lots of different ways to do these questions. Just because you choose a different route, it might take a little bit longer, but maybe it's more scenic. There's more to see on the way, a little less traffic, whatever works for you. So what I'm going to do is I'm just going to focus on everything inside the brackets. And I had this -3 exponent here, and I want to get rid of it because I don't like negative exponents. So I'm going to flip everything inside. I'm going to make my exponent positive. So what I'm doing is just rewriting everything flipped. So I had a -2x to the -4, y to the -2. That was all on the bottom. Now it's on the top. I had a 5x to the -3, y to the -3. That was all on the top. Now it's on the bottom. So what I've done is I've just taken the reciprocal. The reciprocal of everything inside that bracket. Now, I can do a couple things. I have negative exponents inside my bracket. So I can get rid of my negative exponents, or there's nothing saying that I can't just subtract them. I can go -4 minus -3. What does that give me? I can do it that way if I want. What I'm going to do is, I don't like these negative exponents in the brackets, so I'm just going to flip everything with a negative exponent. So if it was on the bottom, I'm going to move it to the top. If it was on the top, I'm going to move it to the bottom. So the negative 2 and the 5 stay there. My power of 3 stays there. What I'm going to do is just anything that was negative, I'm going to flip it. So let's start with this x to the negative 4 here. It was on the top, it was negative. If I want to make it positive, I'm going to take the reciprocal. So x to the 4, I'm going to put it on the bottom. That is the reciprocal. I could write it out in a bunch of steps and have 1 over x to the 4 and multiply it in, and it would just end up back there again. This x to the negative 3 on the bottom is negative, so I'm going to put x to the 3 on the top as positive. I have y to the negative 3 on the bottom, y to the positive 3 on the top. Looks like I lost a y along the way here. Y to the negative 2 on the top, y to the 2 on the bottom. So if it's negative, I can move it to the top or move it to the bottom and it becomes positive. I've taken the reciprocal of everything. The next thing I'm going to do is do the subtraction. So here we go. Negative 2. I have x to the 3 on the top, and I'm going to subtract, and I'm going to end up with 1 on the bottom, and 3 on the top here, and 2 leaves me with 1 on the top. So this may be where you guys were getting a little bit caught up on this one. Normally the number I have on the top here, the 3 in this case, is bigger than the bottom, but that didn't work out this way. So I have 3 x's on the top and 4 on the bottom. So I end up having an x on the bottom, which is fine. There's nothing wrong with that. I have a y on the top, and then all of this is to the power of 3. And an attempt to keep this on the page, I'm just going to put this over here. So everything inside my brackets gets the power of 3. Negative 2 to the power of 3, y to the 3 times the 1 that was there, so that gives me 3. On the bottom I had 5, and then x, so 5 to the 3 and x to the 3 as well. Negative 2 times negative 2 times negative 2 gives me negative 8, y cubed. 5 times 5 times 5, 125, x cubed. So that is kind of as simple as it gets. Anything common between 8 and 125? Likely not. The only thing you don't want to end up with is negative exponents in your answer. So that's kind of the only thing you can't have. So your exponents must be positive. Must. There we go. I'm going to go through one of the next and then the following. I was getting big numbers for A and B. Was I doing something wrong? For this same question, Abby, I assume you're talking about the number we're on here. And then Taylor, you have a question about the 8 and 125. The 8 and 125, Taylor, comes from this 2 to the 3rd power and 5 to the 3rd power. So 2 times 2 times 2 is 8, and 5 times 5 times 5 is 125. You're going to end up with big numbers here because it's everything to the 4th power. I can just quickly go through it. Maybe I won't show as many steps. So the first thing I'm going to do is flip everything. 5b to the 6, 2a cubed, and everything's to the positive. I can't simplify anything, so 5 to the 4th power, geez, what's that going to be? I looked at the answer, they didn't solve the exponents with the number basis. Oh, okay. So if they've left the bases as just exponents, that's fine. I don't know if that's common or not. I would expect that they would actually calculate those out if they're asking us to evaluate. So that's kind of what I'm going to stick with. 5 to the power of 4 is 625. Okay. So everything inside the bracket gets the exponent 4. So 5 to the 4, 625. B to the 4 times 6 is 24. And then 2 to the 4 is going to be 32. 2 times 2 is 4 times 2 is 8 times 2 is 16. 16. A 4 times 3 is 12. So that one doesn't simplify down quite as far. Doesn't look quite as nice. Just kind of what it ends up being. So if you're there, and that's good. Page 7. $10A. Sure, while I'm here. Everything inside the bracket gets to 2. So 4 to the 2, just multiplying these things through. So 4 squared, a to the negative 4, b to the 10, c to the negative 6. Now I know I can't have negative exponents in my answer, so I'm going to evaluate the 4 squared, which gives me 16. I have b to the 10, which is positive, and then I'm going to find the reciprocal of a to the negative 4, put it on the bottom, a to the positive 4, and c was negative on the top, so I put it on the bottom and it becomes positive. So 16b, 10a4, c6. Hopefully that clarifies that one a little bit. I'm going to scroll down to number 4. Well, I guess you guys have the answers to these, but maybe I'll do them anyway. So let's do C here. I have an exponential power and it's negative. So if I want to find positive power, I'm going to have 1 over 5, 5 over 2. This was the common mistake that I warned you guys about. Students always, if they have a negative exponent, they end up flipping the exponent, which is incorrect. When you have a negative exponent, you flip whatever the exponent is acting on. So I had negative 5 over 2. If I wanted to become positive, I'm going to go 1 over 5, positive 5 over 2. I'm going to write it as a root now. Because the bottom or the root is a 2, I don't have to put a 2 out front. I could if I wanted. 1 over 5, and then this is all to the 5th power. Likely would not include the 2 there. So that's that guy. Maybe look at C down here. Flowers the power, roots the root. Write in exponential form. So I have the 5th power and then the 4th root. I think you guys probably are okay with the really simple ones, but when you get a little bit trickier and we kind of mix all the questions up together, it gets really kind of hectic. So hopefully you had a chance to go through those 6. I can do B, sure, for 5. So everything inside the bracket looks like it just has a power of 1. I don't have to write it in, but it's there. If there's nothing, it's assumed to be a 1. So I know I'm going to have 5a, the power of, my exponent was 1, and then my root was 3. So 5a to the 1 over 3. Flowers the power, roots the root, x to the 8 over 3. And same here with this, 3. I have an exponent of 1. I didn't write it in. My root is 5. Yes, Alex, I apologize. I get so excited when I get to these. I take for granted that I've done these lots of times and the exponent laws are really kind of like in my head really well. And then, yeah, you guys kind of are catching up to me. Ava's asked a question. What if you just had the square root around the 5 and not both the 1 and the 5 in your answer? Just the square root around the 5. And not the 1 and the 5? I like up here. So you're saying, well, the square root of 1 is 1 and the 5th power of 1 is 5. So you have 1 over root 5 to the 5. That's fine as well. Same thing. I believe that's what you're talking about for 4c, yeah. So you could write it like that, or 1 over 5 to the 5th. That'll do as well. All the same thing. I guess I just didn't take it a step far enough, because that 1 on the top, square root of 1 is 1, 1 to the 5th power is 1. It's just, if it's got a radical over it, just don't worry about it, sort of thing. Okay, can you do B4C? Yes, okay. Now, there were some additional questions on the learning guide that I didn't go through, and they're kind of way up in chat here now, and I don't remember which ones I went over. So forgive me if you don't mind entering something that you might want me to go over again. I know you already put it into chat, but if we can get them all in the same spot. So anything from the last couple of days you want me to go through in the learning guide, we'll have a few seconds here to go through that. Or if you're all kind of good, then we can just keep moseying on here. See a few people typing, which is good. Yeah, so as the questions coming in here, I just want to remind you guys that in the course, there is some extra practice after lesson 2, so the stuff we did last day. It would be really good. I know you guys don't have a ton of free time, and the learning guide is what you're going to submit. So if you don't do the extra practice, there's no way I'll know, but it's of a tremendous benefit for you guys to the extra practice from probably lesson 2 and 3 even. So if you can find some extra time for that, awesome. But if not, it's not the end of the world. If you feel confident with these questions, that's great. Don't worry about it. But if you're kind of like not super confident in your answer, then you might want to go back and look at those. Maybe even just pick a few of the ones you're kind of struggling with, or ones that look tricky, and go through them, because they are hard questions. There's a lot of steps, a lot of places to go wrong. All right, so a few questions in. Page 5, question 2, A and B, 6A, 5, 1A. Yes. Hopefully that's good, Bill. Yes. Okay, so I'll get to these just a second. Give Belle a second. See if she can get some of that down. Page 5, 2. Okay, let's go up to page 5. I don't even remember what was on page 5. 7, 6, 5. Page 5, 2B. Page 5, 1A. Page 5, 2B, I'll start with this guy here. Both things in the brackets get the exponent of 4. So I get 5 to the 4, m to the 3 times 4. I think we said 5 to the 4 is 625. M 3 and 4 is 12. Next one, page 5, 1A, 2AB. There's 2 2s on page 5. We could write, maybe do this one. I want a positive exponent. I'm going to go 1 over 5 to the power of negative 3. But that's going to change it to positive 3. And this is exactly what I just did, where we had the 1 on the top, and then the, I don't even need that, 5 to the power of positive 3. And then same deal with this, 1 over m to the power of 6, 1 over m to the 6. B, page 5, 1A. Thinking this may be 1A on page 5. Well, that's a bit of a mess of a question, isn't it? 3 to the power of 3, a to the power of 2 times 3 is 6, y to the power of 2 times 3 is 6, 5 to the power of 3, b to the power of 3 times 2 is 6, and 3 times 4 is 12. I can evaluate the 3 cubed as 27, 5 cubed as 125. A, B, Y, Z, all different, so I can't simplify them. That's about as simple as it gets. Page 5, 2B, 1A. Negative exponents 2A and B. Did those? I think I'm good. Okay. I would love to just fly through the next lesson. I know it's kind of frustrating that we're going through 2 today, but the stuff we're going through is just kind of the same rules again. So this lesson isn't anything new. It's just putting everything together. So this is called applying the exponent laws, and it's going to be a little bit different than the stuff in the course, but let's just see if we can get this done. I know we only have like 30 minutes, but see how far we can get. So the very top of the page is just a little box for you guys to have all of the exponent laws in one spot. So see if you can remember product of powers, quotient of powers, power of power, power of product, power of quotient, what these are. So maybe I'll write down the first step and you can see if you can figure out what the answer is going to be from there. So this was the first one, a to the m times a to the n. What is that going to give us? How about a to the m divided by a to the n? What's that going to give us? A to the power of m, and then to the power of n, a and b to the power of m, and a over b to the power of m. What are all those going to look like? Do you remember what happens for each of these things? This is kind of where this section, I don't know if it necessarily gets hard, because when each of these rules is by itself, you guys are really good at them. But when we put them all together, I think students just generally get overwhelmed. But it's all stuff you know how to do, which is kind of, I don't know if it's frustrating, but it's just kind of one of those things where you guys know how to do it. So it's like, why can't you do these questions? You know how to do each of the steps, but when you put all the steps together, it gets hard. All right, a to the m times n is going to give me a to the m plus n. So if I'm multiplying same base, I add my exponents. I'm dividing same base, I subtract my exponents, m minus n. I'm raising a power to the power, I get m multiplied by n. Power of a product would be a to the m, b to the m, and power of a quotient will be a to the m, b to the m. So those are our exponent laws. I guess there's one more that we didn't have. A to the 0 is 1, as long as a is not equal to 0. Let's see how we can put these things to use. No worries, Damon. Do what you need to do. So this is a question where we've been given values for a and b. And it says, what is all this equal to if a is something and b is something? Now, one really sort of important thing that'll make your life so much easier is simplify this first. Once you've simplified it, you should really just end up with something really basic at the end. They're always, not always, the majority of the time these questions are designed to end up with just something easy and simple at the end. So what I'm going to do is simplify it, and I don't know if yours looks as messy as mine, but it's kind of, that's how it formatted, unfortunately. So what I'm going to do is, let's get rid of my negative exponent. So I have a to the 5 on the top, and b to the 8, and then a to the 6, b to the 9, all to the power of positive 2. So that got rid of my negative exponent. I have 5 a's on the top and 6 on the bottom, so I'm going to get rid of all of those and be left with 1 here. I have 8 b's on the top and 9 on the bottom, so I'm going to get rid of all of those and be left with 1 there. So there's nothing left on the top. Do I just write it as a 0, or what is on the top? If I have canceled everything out, what's there? Abby's on it. I have a 1 on the top. A to the 1, b to the 1. This is all squared still. So I've simplified the inside, simplified my brackets. There's just a 1 on the top. Now I need to give everything inside my brackets the 2. So the 1 gets the 2, the a gets the 2, the b gets the 2. So I'm going to have 1 squared on the top, which is 1. A squared, b squared. So at this point, I've simplified. I'm going to rewrite my question. Now I'm going to substitute these a's and b's in. Now I know a is negative 3, so I'm going to put, everywhere there's an a, I'm going to put a negative 3. And everywhere there's a b, I'm going to put in a positive 2. So we're just going to rewrite this. 1 over negative 3 squared times 2 squared. All right, I'm going to evaluate that. 3 squared is 9, 2 squared is 4, and these things are being multiplied by each other. So I end up with 9 times 4 is 1 over 36. So again, I simplified everything. I could have put these a's and b's into the first step here, and I would have had to do like a to the 5th power and then raise it to the 2nd power, and it just would have been a huge nightmare. Really big numbers and then lots of division. But if I simplify first and then put the numbers in, it's a lot more manageable. So that's kind of what this section's all about. It's about mixing all of our exponent laws together, and then sometimes we're going to have to substitute values in for our variables. So we can use the exponent laws to simplify expressions that contain rational number bases. It is convenient to write a simplified power with a positive exponent. Remember, I don't like dealing with negative exponents. You probably don't either. Let's try to keep them positive. All right, let's look at a few more examples here. They do get a fair bit trickier. Simplify numerical expressions with rational bases. Simplify by writing as a single power. Explain the reasoning. All right, we have 0.3 to the power of negative 3 times 0.3 to the power of 5. Now when we're multiplying with the same base, we add our exponents. So we end up with 0.3 to the negative 3 plus 5, 0.3 to the power of 2. Now, we can probably leave it like that, or if we wanted to, we can go 0.3 times 0.3, which gives us 0 0.09. From what I think it was Abby mentioned, that the learning guide is leaving answers like this. I guess it just depends on what type of mood you're in. Do you want to actually take the square of